Hello everyone, welcome to my YouTube channel again. So it's been a long, I didn't actually shoot any videos. So today in this video, I will be talking about an end-to-end project which is called stock price prediction, basically for Bangladeshi stock price predictions. So here is the code structure basically look like. So I have used Lstm based deep learning approach for predicting stock. So the long short term memory, and then I have also deployed the app into Streamlit. So let me go through one by one. First of all, I have created a virtual environment, and these are my requirements.txt file. I have used bdshare library. So this library is basically used for getting the data from API for different stocks. So let me go through this particular library. Just 1 second. So here, if I here is the bdshare API. You can see this is the library where I actually used to get the data. So there are different functions are right there. Get current trade data, based on specific stock name, then get historical data, so the start date and the end date, and based on the data we will got all the data into a data frame, and also get historical data for a specific stock, and then OHL CV historical data, and get DSE index data. So this is the last 30 days market data that actually I will be get using this function, which is called get market info. And here you can see all the functions and the trading news are also right there. So I use this library for fetching the data. Then I have used TensorFlow for training the model, Streamlit app for deploying the app, and also Plotly for plotting the graphs, then scikit-learn for other train test splitting criteria. So if I go to the train function, so this is the train function. Here all of my modules that I've imported, NumPy, Pandas, scikit-learn. From scikit-learn I have used min-max scaler for scale the values, and then I have imported sequential from tensorflow.keras.models, and also import dense Lstm and dropout layer. And from bdshare I have import the get historical data. So here I will get the data basically, and we will pass the symbol. So whatever stock that we want to train the model, we can pass the symbol and it will get the data into a data frame structure. And then this is the preprocess data function. It will preprocess our data. First of all, it will get the closing values and then apply min-max scaler. Then this is the external and Y train. So what I have done is that for I equals to I in range 16 to len of scale data, so I append all the X train and Y train. So basically last 60 days of data basically. So then this is the X train and Y train. Then I have returned the scalar object and also X train Y train value. Then build a Lstm model. So this is a simple Lstm model. I have imported the sequential module, and here the Lstm module I have passed inputs equals to 50 inputs, and the input shape, this is our input shape. And then I have added dropout equals to 0.2, then another Lstm layer, dropout 0.2, and another dense layer with 25 units, and finally the last layer. So the unit equals to 1, that means it will predict only one value. And I have used optimizer equals to Adam optimizer, and the loss function basically means squared error. And then I have trained the model. So model.fit, xtrain, ytrain, and batch size equals to 32, and I have run 50 epoch. Then I have saved the model named Lstm stock model.h5. So you can see here, this is my model. And this is the main function where we will first get the data, use the train test split, build the Lstm model, train the model, and we will finally save the model. So this is the main functions, and after running this script, here is my model. And then so I have my model ready. So let me go to the app.py file. So here, this is a simple Streamlit app where I have added several things. First of all, let me go through the libraries one by one. NumPy, Pandas, scikit-learn, minmax scaler, then load model for loading our saved model, Streamlit, Plotly for plotting our graph, and the BDShare library that we will get the data from this particular library, and also the Plotly. Yeah. So here, convert the image into base 64. So we will show some images. That's why this is the function. So in the images folder, I have some images, test images, also some stocks images, so that I can also show in the Streamlit app. Then this is the fetch data, same function that we have used for trainer.py. So fetch data. So here you will get the specific data based on the start date and the end date. And the pre-processed data, basically these are the closed values. Then I have applied minmax scaler, scale the value, and then finally take the last 60 days of data and added it xtrain and ytrain values. And then this is the load trained model. It will load our trained model from this particular current directory and the predict prices. So basically we will get the inputs, and then based on the inputs we will make the prediction, and the prediction value that we have to inverse transform, basically because we have already used min-max scalar, so we need to inverse transform to get back to our the actual data. And these are the predicted prices that we have got. And this is a simple background CSS script that I have added for some sort of visualizations things. And here you can see this is the title where we can select our stock basically from the drop down, and the default index and the user input. So user can also select from the drop down any stock symbol, and also they can select the start date and the end date as well. And here this is the title with different colors basically I have added, and for each of the data I actually show the table for each of the stock in a tabular format. Then the current trading data, so I have get the current trading data from the BDShare library, also the market information, the AGM news, and the current trading data for this particular stock name. And then I also get the open, high, low, close values, mean value, minimum, maximum, standard deviations, and I have added different colors for each of these things so that we can get highlighted. And then I actually stock price over time. So I also plot some graphs about over time, like the date value and the close value, and also the volume and the date, and moving averages basically for short window equals to 40 means last rolling window for the closing value. We will get all the mean, and also the long moving average, basically last 100 days of moving average. Then we will plot all the values here, daily returns here, and also cumulative returns for cumulative returns, we have the daily returns, and then we have plot based on the date for each of the cumulative returns. Then stock price distribution, like how it actually distributed entire stock, and then some boiler upper, boiler lower values, and also plot them into using these functions. And then stock price versus volume. So these are the this is the plot between the price versus the volume, how much the volume varies when we change the date, and MCAD. So these are some other like statistical analysis that I have done. I have put everything right there: relative strength index, and the candlestick chart, the correlation matrix, price rate of change, stochastic oscillator, historical volatility, and then visualizing the data graph and want to get the data from hovering over the graph, closing price versus time chart, closing price versus time chart with 100 moving average, closing price versus time chart, 100 moving average and 200 moving average. So there are several like plotting that I have added right here. So these before these all of things are plotting. Then I have fetched the data using the fetch data function that I have defined right there. So here the fetch data function, so it will fetch the data based on the specific date that is being put by the user, and we will process the data, then we will load the model, predict the prices, then plot the prices, which is the predicted prices and the actual prices. And here these are some contact information. So let me run this app first. So for running this app.py, we need to so first of all, I actually activated my virtual environment. Then for running this app.py, I will type Streamlit run app.py. So let's wait for running this. So you can see it's running on port 8501 port. So let's just wait for this. And also I actually deployed this same app into Streamlit, so you can also try it out. It's live bd stock streamlit.app. So the URL is bdstock.streamlit.app. So this is a live app that is running into Streamlit. So let me go through this app. Yeah, so see, Bangladesh stock price, this is the logo, Bangladesh Stock Exchange, and the stock symbol. So from the drop down, we can select any stock symbol from this particular stock. And here you can see for example, Janata MFS, stock analysis and prediction using Lstm, data from this particular time period. So basically the time that we have selected right there. Also we can change the time as well. So this is the data for this particular date, symbol, high, low, open, close, trade value, volume, and the current trading data. These are the current trading data. And then market information for last 30 days for this particular stock, and AGM news, then current trading data for Janata MFS, data overview, count, unique value, top frequency, high low value, volume, stock price over time, so how the stock price being fluctuated over the time, volume of stock, traded over time, and stock price with moving average, basically 40 days moving average and 100 days moving average, you can see right there. And daily returns, cumulative returns, stock price distribution, how it actually distributed, then Bollinger bands, then stock price versus volumes, MACD value, relative strength index, RSI, candlestick chart, correlation matrix, you can see right there, and then price rate of change, ROC, stochastic oscillator, then closing price versus time chart. So you can see the values are right there, and closing price versus time chart with 100 days moving average, then closing price versus time chart with 200, 100 and 200 moving average, and the stock price prediction. So basically this is the final thing you can see. So this is our actual value and this is our predicted value. So you can see the stock price, the prediction is pretty much good, like our prediction is 6.117163 and the actual price is 6.1, and the difference is pretty low. Like I have trained only 50 epochs, so the more we actually get the data and the more we train the model, we will get we will reduce the loss. So here you can also change other stock, for example, just 1 second, BBS. Let's see what is the stock for this. So you can see these are all the data, and AGM news, data overview, current trading data, then also all the visualizations here you can see, and the prediction basically. So you can see so here in these points it's fluctuating, but as I actually trained with only ACI dataset, so basically that's why the error is in this case somewhere around 0.8, so like 8. So basically like the more we train the model, the more better result we will get. Also there are some data issues right there, so also if we get more data, the more robust model that we will get. So yeah, that's all from me. So I have also pushed the code into my GitHub repo. You can check this out, which is github.com/kaushik24/bdstock price prediction. So here you will go everything one by one, and you can set up your own. You just clone the repo, go to this particular folder, create a virtual environment, activate the virtual environment, install the requirements.txt file, then just Streamlit run app.py. It will run the app. So here you can see this is my version also. It's been running locally and it's also running in Streamlit, so you can check it out. So yeah, that's all from me today. If you have any queries, ask me in the comment section. I will answer these things. So yeah, thank you.